now we will try to look for derive an expression for azimuth angle. For that what we do is same equatorial plane, this is vertical, okay, equatorial, sorry not equatorial plane, this is horizontal, this horizontal plane parallel to horizontal circular diameter parallel to horizontal plane, equatorial plane is somewhere there, and then this is the vertical, P stands for vertical, the equatorial plane is here, the sun is somewhere there, right. This will be north pole because this is equatorial plane. So, normal to that would be north pole. So, this is north pole, this is north pole, and sun is somewhere there, sun is somewhere there, you know, sun path is somewhere there, this is the sun path. So, somewhere here is the sun path. So, you know this angle therefore, sun is here from the center of the earth, this is the horizontal plane and this is the sun's position. So, this represents the altitude angle, this will represent the zenith angle, this represents the zenith angle, right. So, this point I am interested in sun's point, the vertical and the north pole, vertical and the north pole is somewhere there. So, this is the spherical triangle I am looking at, this is the spherical triangle I am looking at, this is the sun's position, this is the north pole. So, what is this angle? This angle is 90 degree minus delta, 90 degree minus delta. So, this angle is 90 north pole and sun, this is 90 degree minus delta. This is vertical to the sun, that is 90 degree minus, vertical to the sun is basically zenith angle, 90 degree minus altitude angle, and pole to north pole to the vertical, basically I am interested in azimuth angle, So, what is the azimuth angle? Azimuth angle is the angle between sun's position and geographical north direction, this is my geographical north direction. So, this will be my azimuth angle, this is north, this is south, this is east and this is west. So, this is my azimuth angle actually, this is the azimuth angle. So, projection of what is this? Projection of this vertical through the north pole is the north direction. But projection of vertical through the north pole, this is nothing but this line is, this represents this plane along this one, and this is nothing but 90 degree minus latitude, north pole to the vertical, that will be 90 degree minus latitude. So, this is 90 degree minus latitude, this is 90 degree minus delta, this is my zenith angle, and contained angle between this plane and this plane, this plane is my north direction, and this plane, this angle is nothing but my azimuth angle. Angle between vertical north pole, that arc, and vertical and the sun, that would be azimuth angle, because I am taking it from north direction, but anyway it cannot be 0 any time, sun starts from east. So, sun starts from somewhere around this point, but I am measuring the angle from the geographical north. So, line the plane joining in the spherical one, plane joining north pole to the geographical north, that corresponds to my azimuth as 0. So, contained angle is nothing but azimuth angle. So, if I use the concept of spherical triangle again, now this will be this will be, if you remember, this is sin A is 90 degree minus beta, because this is my vertical, this is the sun. So, this is 90 degree minus beta, sin B which is 90 degree minus latitude, and contained angle is azimuth angle is equal to cos of C which is 90 degree minus delta and cos of B A. So, you see AB is azimuth angle, sometimes denoted by phi or AZ, the contained angle, C is 90 degree minus delta. So, put that in the formula simple as this, then you will get it something like point P represents vertical, I am just whatever I stated, it is written here. P represents vertical, north pole and north pole P, point P represents vertical and north pole N as shown. Arcs S1, P, P and P etc. lie on the great circle and form a spherical triangle. The internal angle P of this spherical triangle can be considered, and this is the azimuth angle. So, as I said, and this was cos 90 minus delta, this is angle C. This is called 90 minus S L and 90 minus B. So, this is nothing but sin latitude, sin altitude angle, and this is cos of sine of delta, this is sine of delta. So, sine of delta minus sine beta sine latitude divided by sine cos of beta cos of latitude angle. That is the angle for relationship for azimuth angle. So, azimuth angle is given as sine of declination minus sine of altitude angle and sine of latitude divided by cos of altitude angle and cos of latitude. That means, first you have to calculate out the altitude angle to calculate the azimuth angle. This is one formula. There are some other formulae derived in some other manner, or if it is south is the reference, things might change somewhat. So, this is another formula for azimuth angle. So, I expect that you can really remember this formula, it is not very difficult. So, now summing it up, sine beta is equals to this, we have seen sine altitude is equals to sine latitude, sine declination, cos latitude, cos hour angle, I mean cos declination and cos hour angle. So, sine of altitude angle is equals to sine of latitude, sine of declination plus cos of latitude, cos of declination and cos hour angle. Not very difficult to remember. Solar azimuth is given by cos latitude, one formula is like that, one formula is like that, but we are using a different formula which we have derived. They have a different convention. So, this formula you might find in some books, that is why I have left it, I did not throw it away. Some books you will find this cos latitude sine declination minus sine latitude cos divided by cos beta, derived it in somewhat other manner, because phi is defined in phi is also defined 360 minus phi, otherwise take it from it is depending upon the time of the day. So, convention of defining the azimuth will dictate which formula you are using. We will be using this formula most of the time, you will be using this formula where we define our altitude angle with respect to geographical north clockwise, geographical azimuth angle with respect to geographical north clockwise, right. So, that is what it is, all right. Time, equation of time I have already given you, solar time, equation of solar time I have already given you, right. So, now just small calculation again, supposing declination we calculate out 23.46 other day, let us say declination we have calculated out other day, right. So, latitude let us say 55, this is again same problem, this problem we can verify is there in Marcus and Morris book. Other day we calculated out declination as 23.46, let us say you take from 55 degree latitude. So, this will be sin 55 cos 55 cos 23.6 and time of the 2 p.m. let us say. So, cos 30 comes out to be 78 and therefore, beta is 51 degree, beta is 51 degree. So, you can calculate out back from this just as an example, quick example, and from the formula that is given in that book, if you calculate out, you find it out to be something like 47 degree, but the convention is as per that book's Marcus and Morris book or this formula. You find the same thing with our this formula. If solar time is more than 12, take phi is equals to 360 minus 5, otherwise phi is equals to phi. So, solar time is clock time, etc., etc. But if you calculate from the formula that I have derived, it will give you same. So, this I have just shown you the calculation. Now, let us come to incident angle. When I want to do incident angle, same thing I do. This is my horizontal surface, this is my equatorial plane, right, this is my equatorial plane and this is my surface now, and normal to the surface is this, and it can go to the celestial sphere, normal to the surface or not horizontal anymore, right. So, it is at some angle, therefore, I can define tilt angle here, the angle at which it is there. If it is vertical, it will be 90 degree for others. So, there will be a tilt angle defined here, and this is going up. Now, this was vertical, this is vertical, this is north pole, I think I may not need it right now. This is the normal to the surface touching the celestial sphere NS, right, and what is this? This is the sun's position. So, I can have NS, this point, sun's position and the vertical, sun's position, this something like this. So, something like this I can have sun's position and the normal to the surface I am considering. So, what is this angle? What is this angle from vertical to the surface, normal to the surface, vertical to the normal, normal to the surface. You know, it is an inclined surface onto the ground, its normal is somewhere there and vertical is somewhere there. So, we call tilt angle as this angle. So, this angle also will be normal to the horizontal is vertical, normal to the surface, I am trying to find out the angle between the two. The angle between horizontal and the surface we call it tilt angle. Therefore, normal to the surface and vertical, that angle will be also tilt angle. So, this is tilt angle, this is tilt angle, this is tilt angle. So, one of them will be tilt angle, the other is sun to the north vertical, that is zenith angle, this will be zenith angle. And what about this angle? This angle is normal to the surface and the sun's position, actually normal to the surface and sun position. So, normal to the surface and sun position, what is this angle we call it? Incident angle. How do we define incident angle? Earlier I did. Incident angle is the angle between sun's ray and normal to the surface, right. So, we said normal incidence when say horizontal surface, vertical sun ray, incident angle is 0. At any other, so that is why I said cos theta formula when you are talking about the cosine law. So, this angle is nothing but normal to the surface and sun's ray, this angle is incident angle. So, now you see this is known, sun, the vertical to the sun, this is zenith angle, this angle is tilt angle, and this angle is from the sun to the surface, this is incident angle. This is incident angle, this tilt angle, and this is zenith angle 90 minus beta. What is the contained angle between the two? This is the surface and this is the line joining vertical to the sun ray. This angle between these two is nothing but its angle between these two is what we call wall solar azimuth, because projection of this onto the horizontal plane, projection of this onto the horizontal plane and projection of the sun onto the horizontal plane. So, angle between these two I will be calling, so projection of this is nothing but this actually, projection of this is my wall solar azimuth. What was wall solar azimuth? Solar azimuth minus wall azimuth. So, this is wall solar azimuth. So, contained angle is nothing but wall solar azimuth. So, I can apply the same rule again, right, I can apply the same rule again. So, I applying the same rule, cos of tilt angle, okay, applying the same rule. What is the rule? No, I think there is some slight problem. Let us understand this. This is the wall solar azimuth. So, did I write this? Yeah, cos gamma is very much there. Contained angle is right. That is what I said, is cos gamma. So, it's been written straight away, but I think I can write it like this: sin tilt angle, sin 90 degree minus beta, cos contained angle is equals to cos of that third angle. This is incident angle. I think I should write the formula, remove this. So, let me write it in this formula itself, earlier formula straight away, maybe then I can come back easily. Let me go back to this, let me go back to the general formula, yeah, here. So, this was in that spherical triangle, this angle was nothing but incident angle, cos of incident angle, third angle, right. This contained angle was the wall solar azimuth. One of them was 90 degree minus altitude angle, 90 degree minus beta, and the other one was tilt angle, yes, other one was tilt angle. So, this is S, this stands for 90 minus beta, and this is gamma, and therefore, this the formula will come as cos of incident angle will be equals to cos of tilt angle sin of beta, and here again sin of cos of beta, sin of tilt angle, and cos of gamma. So, that is how, if you just do it yourself, maybe you will get it straightforward. I just wanted to go back there. So, cos incident angle is given by cos of tilt angle, cos of 90 minus beta, and sin 90 minus beta, cos of. So, this will come out to be cos tilt angle, sin beta, sin tilt angle, cos beta, cos of wall solar azimuth. So, you can derive this using concepts of spherical trigonometry. This is shown again just for your to recollect. I can have horizontal equatorial plane like this, same thing I am just trying to show you. This is the sun ray, right, sun position is somewhere there, and this is the sun's path diagram. Okay. So, this is the vertical to the ground. So, therefore, this is how it is. It's been it's just shown again. So, the same thing we are trying to, I am just trying to show you that how all these angles you can represent the same thing I have explained you already, but a second time I am just showing you so that you can understand this properly, right. So, that is tilt angle, incident angle, etc., etc. This is shown, and this is what is contained angle is gamma, and this is I just wrote it. So, this is now detailed, which I just told you earlier in a minute before. This is how the formula comes in. All right. So, this is for the incident angle, sorry, this is for the incident angle, this is for the incident angle. So, you can derive this principle for incident angle. So, we have done now for all angles, actually we have derived expression for all angles. We have derived expression for altitude angle, azimuth angle and incident angle. These are now altitude and azimuth angle defines the location of the sun, position of the sun at that point of time on a given location, and declination, it depends upon latitude, declination and hour angle. Latitude depends upon the location, very simply you would know that. Declination you have to calculate out, which you can calculate from a simple formula I have given. There are other formulae, but I have given the simplest of all. So, altitude angle as easily you should be able to calculate out, and so is the case with azimuth angle. Azimuth angle is also related to altitude angle and latitude angle, and also, and what was it other thing, it was related to cos L, cos beta and hour angle again. So, from this you can find it out, and therefore, altitude, azimuth angle you can find out, and once you have found out altitude angle and azimuth angle, wall solar azimuth angle you can find out, because wall azimuth and solar azimuth, from that you find out wall solar azimuth, and which is here, right, which is here actually. So, azimuth angle you got to find out to find this. Tilt angle is for tilt for the surface. Now, supposing it is horizontal surface, what will be the value of tilt angle? S is 0. So, therefore, sin term, this term goes away. What remains is simply sin beta. So, for horizontal surface, incident angle is simply beta, right. Cos, sin beta is cos I is equals to sin beta, sorry, cos I is equals to simply sin beta. For vertical surface, S is equals to 90 degree. So, since S is equals to 90 degree, this vanishes, this remains. So, this is nothing but cos altitude, cos of incident angle is equals to cos of altitude angle and cos of wall solar azimuth. So, for horizontal surface and vertical surface, equation simplifies. So, this is how you calculate out all these three angles. So, once this you have found out, incident radiation on any surface you can find out, because incident radiation on horizontal surface is known. From that beam radiation you can calculate out using cosine law, which I have given you earlier in the second lecture, and then you can find out radiation falling onto this. So, detailed radiation calculation you can calculate out on any surface if you know radiation on horizontal surface, which is a meteorological data, and therefore, you are writing a program or something built in your own thing, it will be there, but anyway many of those the softwares do the calculation as accordingly. Now, having now knowledge of all these factors, a little bit of equations for calculating radiation and things like that, now we can look into environment, classify the environment, and this classification is environment done in terms of climate. How? Climate is basically the pattern of variation in temperature, humidity, atmospheric pressure, wind velocity, precipitation, etc. in a given region over long periods. That is what is climate, it is the pattern of variation. Climate is a pattern of variation, right. Okay. Hence, climate refers to pattern of seasonal variation at a location. As I said, it is periodic, 365 days. You have looked into Sun Earth relationship. So, you understand that the Earth revolves around the sun in a year around 365, periodicity is around that much, 365 days a year, and during this time the radiation received onto the location, it differs from time to time of the year. Therefore, you have a pattern. So, this pattern varies, periodically varies, and this pattern this pattern of variation of this temperature, because it is variation of temperature, relative humidity, atmospheric pressure, wind, precipitation, everything is governed by solar radiation received there, all right, and its location, proximity to, of course, water body like sea or something of that kind. So, therefore, I can recognize a pattern, and that pattern is called pattern of variation of temperature, etc., that is called climate. Hence, climate refers to pattern of seasonal variation. Now, it will vary when I look at variation day to day. Well, exactly day to day I may not be interested, because perturbation from one day to the next day is so small, I may not be interested, but I can find out seasons, number of days put together. For example, there can be winter season, there can be monsoon season in tropical India, and it can be dry summer season. So, seasons which are those ones where pattern of variation is more or less similar. So, but season to season variations are there, because there is a complete yearly variation. So, every year you will have a summer season, winter season, and etc., etc. So, refers to seasonal variation at a location. So, basically if you define it a little bit more formally, climate is the integration in time of the physical states of the atmospheric environment. Climate is the integration in time over the period of time, physical states of atmospheric environment, and is characteristics of certain, it is a characteristic of any geographical location. For any location, the climatic or variation of this pattern of environmental factors, they will vary. So, therefore, this pattern is a function of the geographical location. So, therefore, for the whole globe geographical location, I can look into different scenarios or divide them into different zones. Weather, on the other hand, of course, is a variation, daily variation, diurnal variation, daily variation, today's weather, tomorrow's weather, because there will be still variation from day to day, which is again periodic, but not necessarily absolutely same every day. Many things are same, but sometimes there could be variation, and that variation we call it weather. So, I can divide then, therefore, whole of the globe, whole of the globe I can divide, because I have latitudes which I can draw as equatorial plane, latitudes, right. These are the latitudes, if you remember, I can draw it like this, this is the latitude angle. Now, as you remember, sun's radiation falls normal only between 23.5 north to 23.5 south, while somewhere beyond that sun's radiation, direct radiation normally never reaches, normal radiation never receives. So, therefore, the temperature will be lower there, because it receives less radiation, and correspondingly every other thing will be, and we have also seen the wind variation is caused by the sun's radiation falling onto Tropic of Cancer, Tropic of Capricorn, etc., etc. So, we classify 3 zones actually, whole globe. So, up to 30 degree plus 30 to minus 30, plus minus 30, we can consider one zone which we call as tropical climatic zone, tropical, broad tropical climate, we call it, the climate there is tropical climate, and 30 to 60 on this side and 30 to 60 on the other side would be subtropical, beyond that is polar, right, 60 to 90, 60 to 90 Arctic or Antarctic, whatever it is. We are not in our class, we are interested in this plus 30 minus 30, because your like building design is more complex there, because you might have summer, winter, everything put there, where monotony is relatively less in subtropical climate. Monotony is relatively less. It is cold, yes, very cold, but then it is cold and cold, maybe some places a little bit of summer, but that too the temperatures do not go as high as tropical climate. Variation in tropical climate is much. So, it is different kind of a challenge. So, we are trying to look into this. So, tropical climate, therefore, we define something like tropical climate is the climatic zones around Tropic of Cancer and Tropic of Capricorn. thus would largely be found within 30 degree north to 30 degree south. Heat rejection and keeping the building cool are the dominant requirements in this climate, right. Other places loss of heat is, they would be bothered about loss of heat, they would not like heat to be lost from the building, while here we would like to keep the heat away, as well as sometime we would like to see that it comes, right. So, that is the point. So, tropical climate again is classified into the climatic zones, and these are hot dry climate, warm humid climate and composite climate. So, these are the main climatic zone in tropical climate. I suppose if this like originally this was given, I do not remember the name exactly, but it is there in the reference that I have given you, or the typed material that I have given you, it would be there in this one. So, hot dry climate, warm humid climate and composite climate, that is the main classification of tropical climate, but there are sub classifications, I will come to that. So, let us say what is warm humid climate? The example here is Mumbai. I am not sure very clearly, you can see the diagram, but does not matter. Main important thing is you can see the temperature variation. This is the mean temperature, mean monthly temperature being shown here. In fact, we represent temperature, you cannot represent 8760 temperature, you can deal with if you are if you have a program, but you want to get an idea about the climatic zone and all, you do not deal with 8760. What is 8760? 365 into 25, 24. How much it is? It will come to 8760 or some such value, right. So, that many hourly temperature, or if you want to go further maybe minutes, seconds, it will be really messy to handle this. So, what we do? We take mean monthly temperature and maybe monthly maximum, monthly minimum, but here for climatic understanding monthly mean is good enough. So, if you see monthly mean somewhere around January, February, March, April, May, this shows in Mumbai this temperature is somewhat higher, but the variation between these two is not very high compared to the next diagram I will show you. Relative humidity is fairly high, 60, 90, etc., etc. So, one of this, again this measured 2 times a day. So, one can have maximum temperature and monthly minimum temperature, maximum temperature and minimum temperature. The dotted line shown minimum temperature, the farm line shows maximum temperature. When it comes to relative humidity, you can have similarly maximum relative humidity, daily maximum relative humidity and daily minimum humidity. Now, which time you will have maximum humidity? Early in the morning when temperature is less, and in the afternoon it will be less. So, minimum, so it's early in the morning because it is related to temperature. So, when a low temperature, relative humidity is higher, assuming absolute moisture content is same. But if there is a precipitation, if there is a rainfall, absolute moisture content will also change, absolute moisture content will also change. So, we will discuss about this climate thing just again for after a small break, all right.